Okay, so the last bit of notes, we're going to look at how to sketch the graph of a hyperbola and how to prove that an equation is a hyperbola by using completing the square. So the rules for drawing the graph, you still want to start with the center of the hyperbola first, using the h and the k values. And then the number underneath x, whether that comes first or second, that will determine how far out to the left or right that you should be drawing the sides of a rectangle. So I just go out to the left and right that amount, and then draw a little dot, and then I fill in the box a little bit after. The number underneath y, whether it comes first or second, doesn't matter. The number under y will determine how far out to draw the top and the bottom sides of a rectangle. So again, I just go up and down that number underneath y amount, and then draw dots, and then I fill in the box afterwards. Next, if you look at the corners of the rectangle that you have filled in, you will lightly sketch some asymptotes passing through the diagonals. And then the last thing you want to look at is if the equation started with an x, if you have this case, then the hyperbola should be touching the sides of the rectangle and then approaching the asymptotes on the top and the bottom. So get closer and closer to the asymptote, but never cross it. If the equation instead starts with a y, so if you have the second standard form here, then the hyperbola should be just barely touching the top and the bottom of the rectangle you drew. And then again, they will go out to the sides, getting as close to the asymptotes as possible. So the only thing you really want to have drawn in darkly is the actual hyperbolas itself. Everything else that I do, like the asymptotes and the rectangle, I try to draw those very lightly or with a dotted line or different colors or something to make it clear what the actual hyperbola itself is. Everything else is just there to help you guide the shape. So here is our first example for graphing, and you'll see that our center on this one is 0, 0. So I'm just going to put a dot down there for reference. And then the number underneath x, square root of this is 5. So I'm going to go right 5 and left 5 and draw two little dots very lightly. And then for the number underneath y, square root of 16 is 4. So I'm going to go up 4 and down 4. So basically, we have these sides of a rectangle that are going up and down, but I'm only going to keep going until I hit the point of the bottom of the box, because then the bottom of the box comes through here, so I don't want to keep going lower past that point. And then going to the left, I keep going until I pass this point. So now I'm going to stop and extend up, and then I'm going to stop because now I see I'm at the highest point of my box. So I'm going to extend over to the right. So you're just kind of filling in the box that you got from using the number under x and the numbers under y. Then I said that you should be lightly drawing an asymptote that passes through the diagonal corners. Now again, this is something to draw kind of lightly because this is not the hyperbola itself yet. This is just helping me figure out the shape of the final hyperbola. And then once you have the box and the asymptotes sketched in, now we look at the fact that this one has y squared coming first, which means it's the up and down hyperbola case. So I wanted to touch the y values, and I'm using a completely different color for this, and now I'm going to draw it solidly. So this is going to extend out and get close to the asymptote, but never actually touch it. And then the other y value is down here at the bottom. Same thing, it's just going to touch the bottom edge of the box, and it will extend out towards the asymptotes that I drew, but it will never actually cross it. So the red lines there are the graph of the hyperbola itself. Everything else is just to help me determine that shape. Here's a second quick example with the center being located somewhere other than the origin. So starting with that location, it's going to be left 2, up 1. So start from the origin, go left 2, up 1. This is the center of my graph that everything will be based around. Now my x's and my y's flipped, but that doesn't really matter to me right now. The number underneath x, if I take the square root of it, it's 2. So I'm going to go right 2, draw a dot, and left 2, draw a dot. And then for the numbers underneath y, square root of 9 is 3. So I'm going to go up 3 and down 3, because y always dictates up and down motion. So here you can see the ends of my box. Like I said, just extend the tops until you hit the side values, and then I can extend down. And then I hit the bottom value, so I'm going to extend back over. And then I hit this value, the left side, so I'm going to extend back up. So there's my box. And then if I connect the diagonals. Doesn't have to be super precise, but just going diagonally through the corners. Those are the asymptotes of my hyperbola, and I'm trying to keep those lines as light as possible. Then I'm going to change colors that I'm using, or just make sure that it's very darkly colored for the last part, the hyperbola itself. This one has x coming first. So now I do care what comes first or second. Since x is coming first, that means I use the sides of the boxes, the x values of the boxes. So here is the right side endpoint, and it's going to go out and get closer and closer to the asymptote but never touch it. And if I went down, it gets closer and closer to the asymptote but it never touches it. And then I need the other side of the box from the x value, up but not crossing, and down but not crossing. So this is my hyperbola. Everything else is just kind of there to help me, to help guide me to that shape. So that's it for graphing. Okay, now for the last part, the last concept we're going over with hyperbolas, we need to see how to put it into standard form in case it's in a different form. So usually this is done with completing the square. We're going to get all of the x and the y terms on the left-hand side of the equation, because if you look at standard form, x and y are both on the left. Only a 1 goes on the right-hand side. So move x and y to the left side, move all of the constants, the ones that don't have any variables with them, to the right-hand side. Second, make sure you check for any coefficients on the x squared and the y squared terms. There should not be a number attached to x squared or y squared. If there is, then you need to factor it out from all of the x's or from all of the y's, whichever one has a coefficient. There should not be a number attached to those squared terms. Next, you do the completing the square process. So this is where you take half of the middle number, square it, and add the number to both sides of the equation. That'll let you get the x's and the y's into a nicely factored form. And then your last step is, since the right-hand side of the equation needs to be equal to 1, you're going to divide every single term. You should have 3 different values. You're going to divide all of them by whatever number you have on the right side of the equation. That way it'll change the right-hand side of the equation into a 1, and you'll end up with your fractions on the left-hand side. So here's the example we'll be practicing with. First, I do want to group together the x's and the y's. So I'm going to take my x squared and my negative 10x, put those next to each other. And then I'm going to have my negative 4y squared and my positive 24y. But the negative 15, the number that's by itself, I'm going to move that to the opposite side. Now this one does have the step 2 problem. I can't go on to completing the square yet because I have a coefficient on the y's, on the y squared specifically. X squared is fine, so I'm just going to leave that one alone. In fact, I'll just go ahead and draw my parentheses for that. This one is fine, so I'm going to leave a blank space for when I complete the square. But on this part, I need to get rid of the negative 4 that's attached to y squared, so I'm going to factor negative 4 out from all of the y's. So if I take negative 4 out of the first term, that leaves me with just y squared. And then 24y divided by negative 4, since I'm factoring it out of this, that leaves me with negative 6y. I see a lot of students fail to do the sign change here when they factor out a negative number like that. So now if I'm just looking at what's inside the parentheses, now my x squared and my y squared both are ready for completing the square. So half of the middle number is negative 5. If you square that, you get a positive 25. And we are going to add that number to both sides of the equation. Because I was saying the left side equals the right side, they wouldn't be equal anymore if I added 25 over here and didn't also add 25 to the right side. The y case is going to be a little bit trickier. My middle number is negative 6, so if I cut that in half, that's negative 3. And then when you square that number, that's a positive 9. But since I did factor a number out, make sure you recognize that what we actually did was not add 9 to the left side. Because of the distributive property, I was actually subtracting 36. If I wrote out this whole left-hand side of the equation, I have negative 4 times 9, which means I subtracted 36 from the left side. So again, to maintain the balance, keep things equal, that means I have to subtract 36 from over there. Now I can factor this down nicely. The two numbers that multiply to 5 and add up to negative 10, that would be negative 5 and negative 5. Or just remember my shortcut, it's always the variable and half the middle number after you complete the square. And then for the y term, same thing. My variable is y, and half of the middle number was -3. If I combine the like terms over here, 15 plus 25 is 40, and 40 minus 36 is 4. My last step is that I need to turn this into a 1, so I'm going to divide every single term by 4 and reduce if possible. So now this will be x minus 5 squared over 4. This one here, the 4's are going to cancel out, so you actually don't really have a fraction anymore. So I'm just going to write this as minus y minus 3 squared. But if it helps you for visualizing purposes, remember that technically that means that we're dividing by 1. I'm just not writing that because dividing by 1 is unnecessary. It is still a fraction, it's just that it's divided by 1. So I'm going to leave it this way. And then 4 divided by 4 is equal to 1. So now we have our standard form. In this case, now I know that a is 2. This means that b is 1, because if you took the square root of the denominator, which is 1, the square root of 1 is 1. So I still know my a, my b, my h, and my k, and then I could find c as well if I wanted, because 4 plus 1 would be 5. You're adding those together, and that's c squared. So that's it. We have proven that we have a hyperbola because completing the square enabled us to get it into the standard form of a hyperbola. So that's all for our studying the hyperbola shape.